Welcome. Let's understand association analysis. Association analysis is the task of uncovering relationships among the data. Association rule is a model that identifies how the data items are associated with each other. For example, it's used in retail sales to identify items that are frequently purchased together. So, what is a rule? The structure of rule will have if condition then result. For example, if a customer purchases Coke, then the customer also purchases orange juice. The first part is the rule body, and the second part is the head. So, what is the strength of rule? How certain is the rule? Confidence measures the certainty of rule. It's the percentage of transactions containing all the items stated in the condition that also contain the items in the result. So confidence of A is equal to percentage of B by A. For example, for the rule if Coke then orange juice will have confidence of 100%. How often is the rule occurred? Support measures the usefulness of a rule as a percentage of transactions that contains all items in the rule. So support of AB is equal to percentage of AB. For example, for the rule if Coke then orange juice, we have 5 transactions and 2 contain both Coke and orange juice. The support of rule becomes 40%. Let's understand association rule mining. It's a two-step process. So first find k item sets where k might be 1, 2, 3, and so on. All items in a rule are referred to as an item set. The rules that contain k item form k item set. The occurrence frequency of an k item set is the number of transactions that contain all k items in the item set. So, an item set that satisfies a minimum support is called frequent item set. For generate strong association rules from frequent k item sets, we use rules that satisfy both minimum support threshold and minimum confidence threshold. These rules are called strong rules. Let's understand a priori algorithm to find all frequent k item sets. A priori principle states that if an item set is frequent, then all of its subsets must also be frequent. This is a diagram to illustrate a priori principle. Here we have shown all the item sets of A, B, C, D, E. We've also shown prune supersets. Let's understand a priori algorithm. Here, first initialize k to 1, then generate frequent item sets of length 1. Repeat until no new frequent item sets are identified. Then generate length k plus 1 candidate item sets for length k frequent item sets. Prune candidate item sets containing subsets of length k that are infrequent. Then count the support of each candidate by scanning the database. Then eliminate candidates that are infrequent, leaving only those that are frequent. Let's learn how to generate strong association rules from the frequent k item sets. For each frequent k item set, generate all non-empty subsets. Then for every non-empty subset, generate the rule and the associated confidence. Then output the rule if the minimum confidence threshold is satisfied. Let's understand multi-level association rules. It's difficult to find strong associations at very low or primitive levels of data. For example, few people may buy IBM desktop computer and Sony printer together. Many people may purchase computer and printer together. So it becomes difficult to find strong association at this level. Let's understand concept hierarchy. It defines a sequence of mappings from a set of lower level concepts to higher level concepts. For example, here IBM, Microsoft, HP are given higher level and computer software printer and accessories are taken as low level concepts. Steps to be followed are top down progressive deepening approach. So first mine the high level frequent items, then mine the lower level frequent items, and so on. For each level, use a pre-algorithm and use uniform minimum support for each level. Then use reduce minimum support at lower levels. Let's understand sequential association rule. It's concerned with sequences of events. For example, new home owners will purchase shower curtains before purchasing the furniture. Then, when a customer goes into a bank branch and asks for an account reconciliation, there's a good chance that he or she will close all his or her accounts before. Transaction must have two additional features like a timestamp or sequencing information to determine when transactions occur relative to each other, and we should have identifying information such as account number or ID number. Let's understand some important parameters. Duration. Duration may be entire available sequence in the database or a user selected subsequence. For example, it might be an year 1999 event folding window. A set of events occurring within a specified period of time, such as within the same day, can be viewed as occurring together. Interval between events in the discard pattern. Zero interval zero means to find strictly consecutive sequences. Interval in between min int and maximum interval means to find patterns that are separated by at least minimum interval, at most maximum interval. Interval is equal to C means we have to find patterns carrying an exact interval. So what are some practical issues? Practical issues may be time window of transactions, level of aggregation, level of support and confidence. Let's understand time window of transaction in detail. Select the time window for transaction covers at least two product cycles. So for example, a customer purchases a product with frequency of 6 months or less, then select a 12-month window of customer transaction data. For frequently purchased products, a short time window is sufficient. Whereas for low frequency items, a longer window is necessary. Let's understand level of aggregation. If product codes in the data are too specific, such as based on product details such as size or flavor, then few associations will be discovered. So group products into categories according to the product hierarchy, then create new level manually. Level of support and confidence. Start with a high support and gradually go on reducing it. Set the confidence to around 50% to reduce the number of permutations. So we understood association analysis rules such as multidimensional and sequential association rules. We understood A-P algorithm in detail. We analyzed various practical issues in association rules. That completes our tutorial. Pick up any further tutorial of your choice and browse through it. The sections are free and self-guiding. For further help, visit us at www.dataminingtools.net.